Hello, I'm Saahil Jain. I'm the CTO here at U.com. When we started in 2020, we saw an opportunity to redo search for humans. At that point in time, Google's experience had not changed much, and we believed that we could do something new given all the innovations happening with natural language processing and the rise of the transformer model. A lot has happened since then, and we've constantly been iterating with the advances in AI. In 2022, with the release of ChatGPT, we saw a new form factor emerging, which was, LLMs being, a new form of interaction with humans. And given that we had been working on search since 2020, we used this as an opportunity to integrate a lot of the advances in AI with these large language models with search. A couple of weeks after ChatGPT launched, we did realize that one of the pieces missing was lack of grounding from the web. And that's why we introduced what we called UChat at the time. And ever since then, we've been evolving, and search has been the through line throughout our journey as a company. Most recently, we've seen the rise of agents. These models have now become good enough where they're able to, independently operate and make queries themselves. At this point in time, we're now focused on building search for AI agents. And one of the great aspects or interesting aspects is that information retrieval and search, while it's changed, some of the fundamentals still do remain. And we're constantly battling and really thinking through what is changing in the world of search for agents, what is remaining the same, and how do we leverage a lot of the best practices and innovations over the last decades with a lot of the new innovations coming out of the last couple of years. And that's kind of the constant tension that operates in our mind, and I think is at the core of building an innovative product when it comes to search for AI agents. We believe that the future of search will be largely driven by agents. The reason for this is plentyfold. One reason is that humans are now interacting with agents more than ever before, and this will continue to increase as a trend. For example, when it comes to planning a trip, in the old world, you would do 100 Google searches yourself, aggregate the information, and then create an itinerary. At this point, individuals are now going to agents, which are conducting searches on their behalf, often hundreds of thousands of searches, combining the information and presenting it back to humans. We see this trend accelerating in almost every field from enterprise to consumer. And because of that, the number of agentic searches is going to increase, and it'll dwarf the number of searches being conducted by humans. This is why we believe that it's really important to build a search API for agents. Agents have different properties than humans. They can process information differently. And because of all these different constraints and skills, search for agents needs to look really different than search for humans. We're in the early innings when it comes to search for AI agents. And the reason for this is that agents only recently got good enough to use search. You could not have even really built a product using search for agents back in 2020 because agents weren't good enough. Only now in the last year or so have we seen, and this is kind of informed by some of our learnings when we launched one of the first products that were combining LLMs with web search. This is kind of when we realized that you need to do it differently for agents. Humans and agents process information really differently. On the one hand, humans process information sequentially. We can only do one search at a time. Agents, on the other hand, can do hundreds to thousands of searches in parallel, and we expect this trend to continue and accelerate over the next couple of years. Search designed for agents needs to bake this assumption in at the core. Another example of a difference between how humans and agents process information is how we look at results. A human, when presented with 10 to 100 results, will pay attention to the top couple results and ignore the rest. Agents, on the other hand, have the ability to process all of the results, and this can be radically modified based on the agent itself and the use case. Humans are lazy. When we do searches, we're very unlikely to take the time to customize and modify the settings and the parameters around search. On the other hand, agents are not lazy. They're very willing to heavily parameterize their searches. This means that when you give an agent more options on controlling the search, everything from search depth to region to advanced settings, they're more likely to use it. This means that we're designing search for a new power user, AI agents. So to recap, agents and humans are processing information in fundamentally different ways. And this means that we need to design search infrastructure that accounts for these fundamental differences. We believe that there's going to be two really big types of horizontal AI technologies, both of which complement each other. On the one hand, there's core intelligence. These are the foundation models that are highly intelligent and capable of reasoning at levels that we've never seen before. And on the other hand, there's what we call augmented intelligence. These are the core tools and services that are guiding these foundation models. Foundation models or core intelligence needs augmented intelligence to produce AI agents that work. We believe that search infrastructure is going to become more and more essential to AI agents. And this is both as a function of utility as well as just economic spend. What we're seeing right now is the difference between AI agents that work and AI agents that don't is often not how well they reason. These models are highly intelligent. It's the data that they have access to. And this is why AI agents that are performing at the highest levels need access to the best search APIs. And that's what we aim to provide. And then from an economic level, over the last couple years since the launch of the first LLMs, we've seen token costs significantly decrease. The trend for token costs are that they are decreasing over time. However, we've seen search costs stay the same, if not increase. What this essentially means is that more and more folks are going to be spending more money and time on the search layer. This is where we want to come in. We believe that search is emerging as a core bottleneck when it comes to agents. Search and information retrieval is a core primitive when it comes to building AI agents for a variety of reasons. Most AI agents need the ability to access the external world, and search information retrieval is how agents do this. The question that might pop up is, should I build my own search layer or should I buy a search API? You can host your own open source model, but you can't host your own web search index. And there's surprisingly few web search indices on the market. We want to be one of those folks democratizing web search by allowing you to use our openly accessible web search API. It doesn't make sense for most folks to spend the raw compute capital to build and expertise to build their own search APIs from scratch, but rather it's much more cost efficient and effective for companies to use web search APIs. And one of the interesting aspects of it is that there's not that many web search APIs on the market. When you kind of drill into it, there's Google, which is kind of your gated world, Bing, which doesn't offer their search API, and then there's a whole host of what we call Google SERP APIs, which are scraping Google. This is a vacuum in the market right now, and we want to be able to democratize search so that other folks can build their own experiences using our search APIs. We take on a lot of the risk, from an infrastructure standpoint, from a cost standpoint, from a research standpoint, building out our web search index so that you don't have to do that on your end. The industry right now is really obsessed with leaderboards for a couple of reasons. The main one is that it's measurable. I think when you're trying to make a decision of which API to use, it's often easy to look at a leaderboard, see a metric, and then default to that option. However, there's a couple different problems around leaderboards. One of which is there's a distribution shift between the benchmark and then your actual task. We've seen this with many customers. Whenever we release an API, we want to make sure that API is easily reproducible on public benchmarks. Another reason is that benchmarks often are very useful for testing our APIs on difficult questions. For example, there's benchmarks that focus on deep research, there's other benchmarks that focus on simple questions, there's benchmarks that focus on multi-hop reasoning. We want to make sure that our APIs do well across benchmarks for a variety of our customer use cases. That said, there's a couple downsides when it comes to benchmarks. One of which is the distribution shift between a public benchmark and your actual agentic use case. At U.com, we go one step further. We do want to perform well on benchmarks, but it's even more important that we perform well on your actual use case, which is why we work hand in hand with customers to produce custom evals for their particular use cases and bridge that gap. A second reason they're different is that benchmarks often don't tell you the full story. What benchmarks do show is one number that indicates your accuracy or performance in a particular task. However, it hides the variance behind that number. And variance can come from different sources. We've actually done research on this here at U.com where we've quantified variance that comes from agent inconsistency and task difficulty. Oftentimes, variance on a particular benchmark stems from an agent being really inconsistent instead of just the task being different difficulties on a particular benchmark. And this can be problematic because when you're deploying agents in in very important production workflows, you need your agent to be consistent. The world has changed a lot since I was doing research at the intersection of AI and healthcare at Stanford. Back then, a lot of my focus was on extracting information from medical reports. And the reason for this is that it's really important to structure information so that it can be used downstream in a variety of use cases. This need to have highly reliable information is still true even today. Even now we work with a variety of companies, some of whom are in healthcare, to provide really accurate information. And I think that experience of working with healthcare data early on has set the tone for some of this work that we do now, which is often used in highly regulated industries where trust is really important. We're at a really interesting time when it comes to artificial intelligence right now. It's as if we've built self-driving cars before we built roads and highways. Self-driving cars were developed long after roads and highways were set up, and now they're functioning and operating on those roads and highways. These foundation models have become so intelligent so fast that they actually have been developed without many of the roads and highways existing that connect them to the world. This is where AI search infrastructure comes in. We're building the roads and the highways that are allowing foundation models to go further. One of the reasons I'm so excited is that we have the opportunity to guide these foundation models in a positive direction. In order for us to have AI that is useful and safe, that AI needs to be grounded with information that is both useful and safe. And this is where we come in. We want to build these tools and services that allow foundation models to gather and then act on high quality, verifiable, trustworthy information. When we started off in 2020, we took this really wild bet that search was in need of change. There's been a graveyard of startups and companies that have tried to revolutionize search, and that was daunting, but we took this bet because we believe that there were a lot of changes happening in natural language processing that were opening up a better future for search and information retrieval. In 2022, we launched one of the first search engines that combined LLMs, these large language models, with web search. And ever since then, we've realized that we want to dive deeper and deeper into building web search for not just humans, but AI agents, which are the new power user of the future.